Alright, it's time for some rational exponents. So our objective of the day is going to be that you're going to be able to simplify expressions with rational exponents. Rational exponents. Well, if you remember, rational would be like a fraction. Oh, yeah. So if we were to do this in our calculators, 4 to the 1/2 would give us 2. Now it's not 4 times 1/2, it's 4 raised to the 1/2. So if you were typing it in your calculator, do 4, the caret, and then 1 divided by 2. Some of your fancier calculators will look like this. 4, then there will be a little box, and you type in 1/2 up in the box. And you get 2. Basically saying that's the square root of 2. Well, that's fun. The same goes with the 16 here. 16 to the 1/2. Well, 16 to the 1/2 isn't going to be 8. It's not 16 times 1/2. It's like the square root. So what we'd end up getting would be 4. And we can try some of these other ones. 27 to the 1/3. The cube root is essentially what that is. It's going to be 3. 16 to the 1/4. The fourth root. If you were to type that into your calculator, you'd end up getting 2. 2 to the 4th is 16. 16 to the 1/4 is 2. Alright, so let's keep thinking about these fractions as basically being, they're kind of like the roots. So raised to the 1/2 is the same as the square root. Raised to the 1/3 is the same as the cube root. Raised to the 1/4 is the same as the fourth root. Raised to the 1/3. Ooh, we're going to get some kind of decimal. Which will be about 1.44. So roughly that. We'll use the squiggly equals. Okay. Again, it's not 3 times 1/3, it's 3 to the 1/3. Awesome. So let's go ahead and do some more simplifications. Now this looks confusing. We have the cube root of 27 squared. How about let's take it step by step. What's the cube root of 27? Well, that's 3. Then we're going to square it. That equals 9. Now what you'd actually see if it was written in exponential form, you'd see, whoops, not 9, you'd see 27 raised to the 2/3. So what we have is our denominator of that fraction is like our root. The numerator is like our exponent out here that we have. Alright, so let's take a look at the next one. Square root of 9 is 3, then cube it, we get 27. You could rewrite this in exponential form. Well, square root, it's like, there's a little 2 here, but we don't write that for square roots. Alright, so I'd have 9 to the 3/2, where the 2 is the root, and the 3 is our little exponent out there. Awesome. So essentially what we have here is it would be a raised to the m over n, where n is our root right here, and n is our root, and m is our exponent. I personally like this form best, especially when we're working with calculators. It's easier, it's quicker to write this in our calculator than writing this. Okay, but make sure if you are ever typing that in your calculator, you'd have a, if you don't have the little box, the fancy box, you'd have m divided by n. And you have to have those parentheses when you're doing a fraction like that. Okay, so if you don't have the fancy box, that's what you'll have to do. Going old school with the 83 and some of the early 84s. So let's write each one of these in radical form now. Remember, the denominator is the root. This guy's our exponent. So we have the 7th root of x squared. Try the next couple. Pause it, and then replay. Alright, now that you've tried them, let's rewrite them. Well, I'm going to have the cube root of 4 squared. And the last one, we're going to have the 5th root of y to the 6th. Woo! That's fun. I love this stuff. So let's take a look at this first one. 5 to the 1/2 times 5 to the 1/2. Well, remember, when we multiply like bases, we add our exponents. Well, what's 1/2 plus 1/2? Get 5 to the first, or basically just 5. Excelente. Let's see this next one. We got the square root and the 4th root. I find it easiest if we rewrite these in exponential form. So I'm going to have 10 raised to the 1/2 times 10 raised to the 1/4. Well, we've got like bases, so we should be able to add our exponents. Well, 1/2 plus 1/4. I think I'm going to need a common denominator. Well, the common denominator would end up being 4, so we'd have 2/4 is the same as 1/2. Well, what's 2/4 plus 1/4? That'd be 3/4. So I'm going to end up with 10 to the 3/4. Awesome. That is cool. There's my final answer. And you could, for fun, write it in radical form. So I'd have the 4th root of 10 to the 3rd. Man, it doesn't get any better than exponents and radicals. Ah, so fun. All right, this last one. Oh my goodness, this looks terrible. Well, let's see, x and y, they're not the same, so I can't combine those two. But we know from our exponent properties, because they're going to come back to haunt you this entire chapter, which is why we started with it, I can take this 15 and multiply it to each one of my exponents. Well, 15 times negative 2/3. So I'd have 30 over 3, which is 10, so x to the negative 10th. And then I'd have y, well, you'd have 15 over 3, which is 5, so y to the negative 5th. Well, both my exponents are negative, so I need to take my y and bring it upstairs to the numerator and bring the x down to the denominator. So what I'm going to have is y to the 5th over x to the 10th. And there's my final answer with that one. So using a little bit of exponent practice along with our newfound love for rational exponents that we've got there. And negatives on top of it. You guys can handle anything, though. You're incredible people.